All right, Mr. Ahmed here for 11.3. Goal for today is going to be to find the area of some polygons. And the first two that we're going to look at is a rhombus and a kite. So the formula to find the area of a rhombus and a kite, they're both the same thing. And what we're going to have to do is we're going to have to take 1/2 times one of the diagonals. And when we say the diagonal, it goes from vertice to opposite vertice all the way across. So D1 would be that green segment. And then we would multiply it by the other diagonal, which goes from the opposite vertice all the way across. And that would be the second one. Keep in mind a couple details of a rhombus. The diagonals of a rhombus do indeed bisect each other. So this green segment is cut into 2 equal parts, and so is the yellow one. Okay. With a kite, same exact formula. 1/2 times one of the diagonals. D1 goes all the way across. One of these diagonals will be bisected, the other will not be. And the green one in this case is the one that's bisected. And the other diagonal goes all the way across from vertice to vertice. Excuse me. That is diagonal number 2. So those are the two formulas for the rhombus and the kite. So we're going to first find the area of a rhombus. For me to find the area of the rhombus, I need to take area equals 1/2 times diagonal 1 times diagonal 2. So diagonal 1 in this case, I'm going to go from here all the way across to here. And this piece is 10, so this is 10, so that whole length is 20. So 1/2 times 20 times the other diagonal. Again, it's bisected, cut in half, so we have a 20 and a 20. So that would be 40. When I multiply that out, 1/2 times 20 is 10, and 10 times 40 is 400. And we are in centimeters squared. We have found the area of the rhombus. This one says we have a rhombus with an area of 750 square feet. If E to G is 50, find F to H. So EG, from here to here, that's one of the diagonals. That piece is 50. We need to find the length of FH. So 750 is the area. That's equal to 1/2 times diagonal 1 times diagonal 2. And one of the diagonals is 1/2 times 50 times our other missing piece, that is FH. So half of 50 is 25 times FH equals 750. You could have put an X in there instead of FH. I just wanted to solve for the segment. Now I'm going to divide by 25. And 750 divided by 25 is 30. And FH would be in feet. So 30 feet. I'm just going to put a little exclamation point there for the feet. Or sorry, not an exclamation point, an apostrophe. All right, moving onwards. We have a kite this time. So for us to find the area of the kite, we have to take 1/2 times diagonal 1 times diagonal 2. So area equals 1/2 times diagonal 1 is 40. Times the other one, 56 plus 26. Have to get the whole length. That's 82. So that would be 20 times 82, which is 1640. And our units are in inches squared. So the kites and the rhombi should be fairly straightforward. The more difficult, challenging part of today is the area of regular polygons. So keep in mind, with a regular polygon, all of its sides are congruent and all of its angles are congruent. A couple key terms here. A radius of a regular polygon goes from the center to a vertice. This would be another radius, R. Another radius, R. In a regular polygon, all of these radiuses are going to be the same size. The apothem, A, goes from the center to a side at a right angle, okay? And it also will be at the midpoint of that side. And the central angle is an angle that's formed by connecting two consecutive radii. So this is the central angle right here. I'm going to abbreviate that CA. The central angle is equal to 360 divided by n. So 360 divided by the number of sides. N is the number of sides. For us to find the area of a regular polygon, we are going to have to take 1/2 times capital P. Capital P is the perimeter of that polygon, so we have to find the length all the way around it, times the apothem. So this problem's not too bad if it gives us a side length and an apothem. It's going to be much more challenging when we aren't given both pieces. So this one's not going to be too bad. First step is I'm going to find the perimeter. And in this case, this is a 1, 2, 3, 4, 5, 6, 7-sided figure. So the perimeter would be 7 times a side length, 13.9. So 7 times 13.9 is 97.3. The apothem is given to us. This goes from the center to the side at a right angle, so that's the apothem. So the area equals 1/2 times the perimeter times the apothem. And when I multiply this out, I would have 1/2 times 97.3 times the apothem, 14.4. So I will use a calculator to find that, and then we will have our solution. So make sure I put the 1/2 in parentheses, times 97.3 times 14.4, and we get 700.56. And that's units squared because it didn't tell me what we were working with in regards to feet, inches, or centimeters. So that one wasn't bad. It gave me the pieces that were necessary. These problems will get much more challenging, like this one. In this case, it just tells me the apothem. So for me to figure out what the side is to get the perimeter, I'm gonna have to break this apart into a triangle. Now, when I break it apart into a triangle, that central angle becomes vital. You will have some problems on your homework where you have to calculate the central angle. So I'm gonna abbreviate central angle again, CA, and that's equal to 360 divided by 6. 1, 2, 3, 4, 5, 6. It's a 6-sided figure. 360 divided by 6 is 60 degrees. So a central angle is 60 degrees. Now here's the key. I broke this apart into this triangle. That's not the whole central angle. The whole central angle would go over to here. So the whole thing is 60 degrees. Now here's the key. These two pieces are congruent. That makes these two pieces the same size. And I've broken it apart into a right triangle, okay? Now in this problem, since the whole central angle is 60, this little part is half of 60, which is 30. Okay, I'm gonna actually draw that a little bit easier. 30 degrees, make that even more obvious. So now I need to figure out this piece X. All right, so I'm gonna redraw this here triangle because we know how to find missing side lengths of right triangles. This is a 30, this piece is X, this is 4 times the square root of 3. Now for this problem, this is a 30, 60, 90 right triangle, so I'm going to use a 30, 60, 90 right triangle. This piece is the long leg, and the long leg is equal to the short leg times the square root of 3. That was the equation for a 30, 60, 90. So the long leg is 4 times the square root of 3. That is equal to the short leg, x, times the square root of 3. When I solve, I'll divide both sides by the square root of 3. These cancel, and x is equal to 4. So that means this little part is 4. So the entire side length, if x is 4, would have to be 4 times 2. It would be 4 and 4 to get us a total of 8. So the whole side is 8 units long. So now I can find the perimeter. The perimeter is equal to 8 times 6, because there's 6 sides. 8 times 6 is 48. So we know our perimeter is 48, and I know the apothem is 4 times the square root of 3. So, final formula. Area equals 1/2 times the perimeter times the apothem. You might also see that referred to as apothem times perimeter. It goes both ways. The order's not important. So 1/2 times 48 times 4 times the square root of 3. I'm going to leave this one in exact form. Half times 48 is 24 times 4 root 3. And 24 times 4 is 96 times the square root of 3 equals the area. And that's units squared. I could also get a decimal for that if I chose to. 96 times the square root of 3 is approximately 166.28. And we have found the area. So this one I used a 30, 60, 90 right triangle. All right, on to the next one. This one's even tougher. It only gives me a radius. For me to find the area, I need to figure out the apothem. And I also am going to have to figure out the side length. Now it's a square. If I found the side, I could use that as well, but I am going to use the apothem and the perimeter. So if I break this apart into a triangle here, for me to find the central angle, CA, the central angle is equal to 360 divided by how much? That would be 4, because it's a 4-sided figure. 360 divided by 4 gives me a central angle of 90 degrees. So when I break this apart into a triangle like this, this radius is also 32 times the square root of 3. This is a right angle, and this is 45 degrees, which would also make this 45 degrees. So I'm going to redraw just my right triangle for me to find the missing piece. Oops, got a little carried away there. Bam. And I know this is 32 times the square root of 3. This is 45. I need to find this piece X and this piece A. Now those two pieces on this right triangle, since it's a 45, 45, 90, are the same size. It's isosceles. Okay, so I redrew my right triangle. I can find the missing sides of right triangles. I cannot necessarily find the missing sides of this type of a triangle in regards to the side length and the apothem. So for us to find that in a 45, 45, 90, the hypotenuse is equal to the leg times the square root of 2. In this case, the hypotenuse is 32 times the square root of 3. That equals the leg X or A, either one, it's the same size, times the square root of 2. Now I would divide both sides by the square root of 2, and we will leave it right there. Okay, I'm not going to simplify this and rationalize the denominator. That's not going to be necessary for this problem. So now I know the apothem. Let's just get this as a decimal. Let's roll with that. We'll go decimal in this question. 32 times the square root of 3. Enter. Do the top and divide it by the square root of 2. Press enter, and we get 39.19. And that was X, sorry. 39.19. So now I know the two side lengths. This is 39.19, and this is also 39.19. So for us to find the entire side length, I would have to take 39.19 times 2, and that's 78.38. All right, now I have enough information. So as you can see, the hard part of this is really working with these right triangles. Okay, perimeter equals 78.38 times 4. I just multiplied it by 4, 78.38 times 4. And that's 313.52 equals the perimeter. The apothem is also 39.19. I can plug this into the formula. Area equals 1/2 times the perimeter, 313.52, times the apothem, 39.19. Plug that into my calculator. 1/2 times 313.52 times 39.19. This is a big one. Area is equal to 6,143.42 units squared. We found the area. So this time we used a 45, 45, 90. Sometimes we'll have to use sine, cosine, and tangent to find these missing sides. So in this case, I now have a heptagon. I know the apothem, but I do not know the side. I'm going to find this piece, and I will use Pythagorean's theorem since I know the two pieces. So 2.77 squared, that's the hypotenuse. That would equal x squared plus 2.5 squared. Now I'm going to solve this using my calculator. Let me show you how I'll do it. I have to do 2.77 squared. enter. 7.629. Now, with this formula, I have to subtract 2.5 squared from both sides, so I'm going to subtract 2.5 squared. And I get 1.4299. So x squared equals 1.4299. Take the square root of that. Using my calculator, second square root, second answer. Take the square root of the answer. I got 1.19. So that's that little piece. The entire side length would be that times 2. 2.38. So I now found the side length. I know the apothem. Area equals 1/2 times the perimeter times the apothem. So got to find the perimeter here. I'm just going to put that right down here. Perimeter equals 2.38 times the number of sides. 1, 2, 3, 4, 5, 6, 7 times 7. And my perimeter equals 16.66. I already know the apothem. The apothem was equal to 2.5. Now we can plug it in. So 1/2 times the perimeter, 16.66, times the apothem, 2.5. And we'll plug that into our calculator. So 0.5 times 16.66 times 2.5 is 20.825. And we didn't get units, so it's just units squared. All right. Last one, find the area of the shaded region. So in this case, I have a triangle inscribed inside of a circle. So for me to find the area, I'm going to have to take the circle minus the triangle. Area of the circle is not too bad. I know the radius, so that's pi 8 squared, so that's 64 pi. Now the area of the triangle. That's going to be a little bit more challenging. So again, I got to break this apart. I just know the radius. I have to find the apothem A, and I also have to find the side length here. So first step, find the central angle. Central angle equals 360 divided by 3. It has 3 sides. That's 120. So keep in mind the central angle is the whole thing. So the whole angle is 120, so that's half for this little piece, which is 60. So again, I have a 30, 60, 90 right triangle. So using my 30, 60, 90 right triangle, this is the hypotenuse. The hypotenuse equals the short leg times 2. So 8. The short leg is the apothem, A, times 2. So A is equal to 4. I now know the apothem is 4. And the long leg, X, equals the short leg times the square root of 3. So in this case, the short leg's 4. So X equals 4 times the square root of 3. So for us to leave this in exact form, this entire side length would be 4 times the square root of 3 times 2, which is 8 times the square root of 3. I now know the side length. So finding the perimeter, we'd have 8 times the square root of 3 times 3. It has 3 sides. 8 times the square root of 3 times 3 would be 8 times 3, so 24 times the square root of 3 is the perimeter. So plugging it in for our area of the triangle, that'd be 1/2 times the perimeter times the apothem. Alrighty, plug it in. So 1/2 times the perimeter, 24 square root of 3 times the apothem. Apothem A was 4. And there we go. Let's simplify it down now. Half of 24 is 12. 12 times 4 is 48. So we'd have 64 pi minus 48 times the square root of 3. That is the exact form. Now to get a decimal approximation, I just type that in. 64 pi minus 48 times the square root of 3. I can do that in one step, and I get 117.92. That's units squared. All right, that's it for today. Have a good one.